All right, so I wanted to go through the solutions for homework number one. I know there's a PDF file, but I actually wanted to kind of walk you through how I've been thinking about the solutions and how we come up with them. So this horrible drawing here that you can't really see is supposed to be this coiled spring, and there's like a little Hot Wheels train attached to it, and this is like a loop-de-loop, so it's like a Hot Wheels track. And when we're doing our energy bar graphs, we always talk about what's happening initially and what's happening finally. And what we want to do is figure out where all the energy is stored. So here's what I like to do. I first like to note that yes, there is a spring and it's compressed. And then the other thing I like to note is, well, does it have any speed? And in this case, there's no speed. I also note that its height is 0. So what that tells us in terms of the energy bar graph is since it's not moving, there's no EK. It has no height, so there's no EG. And therefore, all of our energy starts off as being elastic energy. Now, in its final state, the spring has sprung. So there's no more spring energy, so we can just write that off. Now, I told you initially that there was no dissipated energy in this problem, so we're not going to need to worry about that. But in this case, we do note that height is bigger than 0. And we're going to assume that it's moving a little bit. And I'm going to compare question number 1 to question 2. I notice that it's a little less high up here. So I'm going to give it a lot more gravity energy here, like almost 3/4 of it. And then I'm going to put some energy as kinetic. Now the last thing we need to do is we need to write down our initial and final energy conservation equation. So that means the elastic energy. You know what? This is what I gave you in the notes. I said E initial equals E final. And in this case, that means E elastic equals E kinetic plus E gravity. Awesome. Now for the next problem. It's actually a very similar idea. So I'm going to use what I did for number 1 to do this one. So I have all elastic. And it doesn't go as high up as it did before, so I've only got some gravity. And that means the rest of it has to be dumped into kinetic because the spring has sprung and we have no dissipated. Using the same reasoning that E initial equals E final, we're going to end up getting that E initial equals E final. That's going to give us E elastic equals E gravity plus E kinetic. And now that you've had a little experience doing it with numbers, at least A and D period, you can see that even though these equations look the same, we're going to expect to get different answers. All right, for number 3, we have a height of 0 and our speed's greater than 0. That tells us all of our energy is stored as kinetic. And then we're at the top of the hill, so I don't know if there's dissipated energy or not. I'm going to assume that there's no dissipated energy. And since we have height greater than 0, we don't have any springs acting, so all we have here is that E kinetic equals E gravity. Some of you might have done a graph where you said, well, there's gravity and maybe a little bit of dissipated. If you did that, if instead you came up with E kinetic equals E gravity plus E dissipated, that's totally fine. When we actually do problems with numbers, I'm going to let you know about that, like whether there's dissipated or not a little bit more clearly. Like look for words like friction or parking brake or air resistance or things like that. So these are the first 3 problems, and we'll take a look at the next few problems in the next video.